Hello everyone, welcome to the channel. My name is Gaurav Singh from Automation Hacks, and in this video we are going to understand all about Lambda expressions in Java. If you are writing simple Java code, you might not need to write more complex Lambda expressions, but if you are working extensively with say streams or trying to create higher order functions, then this becomes extremely important. Let's deep dive into what Lambda expressions are all about with some simple examples. So continuing in the spirit of this series, I have some bit of learning tests to understand this concept. And let's start that first, right? Now, the first thing that we should understand is how you can actually write a Lambda expression, right? So here I have a simple example of how to create a Lambda. Now, what you can see is I have essentially an interface, right? I'm calling it string appender, and I'll show you what this interface looks like. But essentially, it is uh, that I pass an input to this interface, right? And given that input, I want to do something based on that. So here I'm taking the input and I'm just appending one string to it. That's all. Um, Now, how does this interface actually look like? So this is how the interface is created. What you can see is this is interface like any other called as string appender. It has a method called as append that takes a string and returns a string in output. Now, this is very similar to any other interfaces that you might have created in Java, with one difference that this is annotated with at functional interface. Now, this is something that Java 8 newly introduced, and let's just understand what that is. So essentially, a functional interface is an interface, right, that can have only one method, right? And this is created to ensure that no other person that is working on this code base can accidentally start adding more methods to it. There is an exception to this rule wherein you can have multiple methods declared as default, but let's come to that in a moment and understand that. For now, what you can understand is yes, this is a way for me to create an interface with a single method, and no one else should be able to add anything. So say I tomorrow I want to add like, hey, int append int or something wherein I pass like say int a, right? And let's say it returns an int. What you can see is now I start to get, an error. Basically, that there are non-overriding abstract methods that are found. And it's suggesting us to remove this annotation, right? So just to prove that point. Now, let's come back to our test. So using that, I'm essentially creating this sort of lambda syntax, right? Now, this is a syntax we saw in previous video as well. Uh, and let's expand on that a little bit further, right? So, given that we have this string appender, let's also understand what could be different modes of working with such expressions, right? So here I have an example method called as append string, right? Which takes string as an input, and it also takes this functional interface or lambda as an input. Now, such a function is called as a higher order function within Java. Basically, it's a function that can accept another function as an input. It's a way for you to write some code in more functional style. Let's understand how this append string function is implemented. Not surprisingly, it has the first parameter as a string, and the second parameter is actually a lambda of type the functional interface that we just created. And what I'm doing is I'm calling the append function from my lambda, right? So if you can see, I'm using lambda.append, which is the append method we just saw in our interface, right? And we provided the target. While the example is a little convoluted, it just goes to show that you can write functions which can accept other functions or lambdas as an input, right? And let's see what could be potential usage of this. So yes, I want to check that the result that this higher order function returns, it's equal to basically hello. which is the string that I passed, and from lambda function, which is coming from this actual lambda, right? So let's just run this to make sure this is working fine. And we can see, yes, indeed, this test method works fine. Now, a couple of detailed points that we should understand is while you might be thinking that in previous versions of Java, we had the ability to create anonymous inner classes, right? And how is lambda expression really different from that? Can't I just substitute a lambda for all the anonymous inner classes? While you can, but there is actually a nuance between these two. And I've called that out in this comment because it's very important to understand. So basically, whenever you use an anonymous inner class, and I'll show you an example of that just in a moment, it actually creates a new scope, right? We can actually create some local variables, and they would only be within the scope of this anonymous inner class. That is a class without a name if you're coming across it for the first time, right? And we can also use this keyword within that inner class, right? But lambda expressions actually are different from an inner class in that they work with the enclosing scope. So whatever scope is outside where they are even declared, they can access that, right? And we cannot hide variables from any outside scope within a lambda's body. And in this case, like if you use, the this keyword, then it will actually refer to the enclosing scope. So let's expand that on a little bit just to understand how this works. We'll come to this in a moment. This is another way of, creating a lambda. But yeah, this is what I was actually talking about. Let me expand this. Here what you can see is I've actually created an anonymous inner class, right? Notice that I've created it using a new keyword. I've provided the functional interface, and I've actually created a scope here. Now I've created a variable with the name value and type string, which is having some string. What this is actually referring to is that this value is not going to be accessible from outside, within outside the bounds of this specific anonymous class. And I have also overridden the append function. So previously, as you remember, it would just add, whatever is passed. Here I'm actually formatting the string a little bit. So essentially, I am taking whatever is passed as an input. I'm substituting it in the first value, and I'm also then using a this dot value here, right? Now, as I explained above, this here refers to the anonymous inner class. It shouldn't refer to the value in the outside scope. If you see, I have also added a value here, which is called as outer scope. So I'm expecting that when we check, it shouldn't really refer to that outside scope, right? And now I call the append method on this anonymous inner classes instance, and I pass it Ola, right? So what I'm expecting is, hey, I should have Ola as the first value, and I should have the value which is this string as the second. So let's see if this works fine. And you can see, as expected, as you can see, it actually works with the enclosed scope. So this is a way wherein it's calling out the difference between a lambda expression versus an anonymous inner class. Both have their places, depends on how you want to use them or what is the exact use case you have. Another way for you to create a lambda expression is previously, I think I showed that you can create your own functional interface and then, create it. But if you want, you can just directly use some pre-created functional interfaces that Java also provides. In this case, there is a functional interface called as a function, which basically has, two types defined of string and string. So if you go to this functional interface, what you'll see is this represents a function that takes one argument, right? And then it returns the result, right? And in this functional interface, it basically has it takes t as an input, it has an apply method, and it returns r, among some other utility functions that you might want to use later on. But here I've created this as a sort of function, right? As a Lambda function. And I've had the definition, which is purely identical to what we have above, just that the string is slightly, um, actually, yeah, the string is slightly different. Now, I can again call append string, which is the higher order function that I wrote, where I provide an input and a Lambda function that I want to apply. And now I can just check that the result should be similar to what I expected. Instead of from Lambda function, it just calls as Lambda, right? So let's run this. Yes, this works fine. So this is another way wherein you can use some pre-created functional interfaces in Java to write some higher order functions. I hope this video gives you an idea on what Lambda expressions are all about. Don't worry, the syntax seems a little tedious in the beginning, but once you start working with it, it's actually pretty fun because you can then think about composing functions and get into the realms of more functional programming. I hope this video was valuable to you. If there is something that is unclear, please feel free to add your questions in the comments and I'll promise to address them. And let me know what other topics you would like me to explore in the future. I do read all your comments. Thanks for watching the video. I'll see you next time.